Welcome to this lesson on lithium-ion batteries. This is Will White. In this lesson, we're going to review the advantages and disadvantages of lithium-ion battery technology. Lithium-ion batteries are a group of lithium-ion cells put together into a package. In the picture we see here on the slide, we've got 3 lithium-ion battery banks. Each battery bank in this case has 8 modules in the bank, and each module contains a whole bunch of different cells. I believe in these ones they have over 100 cells in each one of those modules. In order to ensure individual even charging and discharging of all these cells, lithium-ion batteries need what's called a battery management system, or BMS, which monitors the conditions of each cell, usually voltage, temperature, state of charge, discharge, and charging rates, and it regulates charging to these cells based on the parameters of the specific cell. It ensures even charging and even discharging among all these cells, and also prevents overcharging and over discharging of the cells. Lithium-ion batteries in general have a longer life cycle and a higher efficiency than lead-acid batteries. They'll usually last, depending on the chemistry and which manufacturer, somewhere between 4,000 and 10,000 cycles compared to a maybe 1,500 or 2,000 cycles for lead-acid batteries. They're also higher efficiency. Usually they're in the 90% range. Some of them even claim up to 98% efficiency. So you can get more energy out of these batteries compared to what you put in than you would with lead-acid batteries. They're low maintenance. They have no access to the electrolyte, so there's nothing that needs to be refilled. There's really not much maintenance that goes into these. Check the torque on the terminals every once in a while. Make sure you're meeting the manufacturer's clearance requirements around the battery bank. Lithium-ion batteries also have a high energy density. It varies a little between the lithium-ion chemistries. Nickel, manganese, cobalt has a bit higher energy density than lithium iron phosphate, but they're both higher than other battery technologies. So you can pack more into a smaller space. For example, these blue-ion batteries are 16 kilowatt hours per cabinet. So there's 48 kilowatt hours of storage in these 3 cabinets, which is quite a bit. They have a relatively low self-discharge rate. What that means is that when the batteries are sitting fully charged, not being used, they're going to lose some of the energy stored in the battery. The amount that they're going to self-discharge varies depending on chemistry, and lithium-ion has one of the lowest self-discharge rates. So if you're in a situation where the batteries are maybe in a battery backup situation where they're sitting fully charged, just waiting for the grid to go out, they're going to lose less energy and take less generation to keep them recharged than other chemistries of batteries. Lithium-ion batteries are relatively new to the energy storage industry. They are very quickly gaining popularity in residential and standalone or off-grid markets. Historically, lead-acid has been the go-to battery chemistry there, but we're seeing lithium-ion used more and more often in residential and off-grid situations. Lithium-ion has been the market leader in large commercial and utility scale storage for a couple of years now. They have over 90% of the market share, so it's the go-to battery for large scale systems. Some of the downsides of lithium-ion, they are more expensive up front than lead-acid, but those prices are falling fairly rapidly. When you look at the pricing over a cost per kilowatt hour basis, they are much more financially viable. There is the chance of what's called thermal runaway, especially with NMC batteries or nickel manganese cobalt. And what thermal runaway means is uncontrolled heating of the cells. So usually one cell fails, it heats up, and that causes the cells around it to fail, which causes the cells around those to fail, and you have a cascading failure. So safety is something we want to really look at when considering lithium-ion batteries. In the past, there's been issues integrating lithium-ion batteries with the readily available electrical components, specifically inverters and charge controllers and other balance of system components, but the market is maturing to the point where that's much less of an issue, although it's good to make sure that the lithium-ion battery you're considering is compatible with the rest of the components in the system. Lithium-ion is hard to recycle. There's not many lithium-ion recycling facilities around the world, although there are more being built. So as time goes on and as lithium-ion becomes more popular, we will see more recycling facilities. One major downside to lithium-ion is that they often can't be charged below freezing, 0 degrees Celsius, 32 degrees Fahrenheit. So the battery management system will disconnect the charging from the lithium-ion batteries if the temperature gets below that point. This doesn't apply to all batteries. There's obviously exceptions to that, but in general, that's the case. There may also be discharge or charging limits on the high end. Above a certain point, the battery management system will disconnect the batteries to prevent damage to those cells. Lithium-ion batteries, because they are a little more sensitive to overcharging and over-discharging, and they can have those thermal runaway issues, there may be additional requirements for where they can be located. In most places, you can't put them in habitable spaces like bedrooms, living rooms, kitchens. There may be requirements for fire alarms or sprinklers, depending on what codes your jurisdiction is enforcing. So if you're considering a lithium-ion battery storage technology, you should check out the codes and fire requirements in your location to make sure there aren't additional requirements there. Some jurisdictions only allow lithium-ion batteries to be installed outside or in a detached building. So that's something you want to know. There's also shipping regulation requirements specific to lithium-ion. Typically, you can't ship them by air, so they have to go by ground transport. The key points for this lesson are lithium-ion batteries require a battery management system or BMS. All reputable lithium-ion manufacturers that are designing systems for use with renewable energy systems will include a battery management system with their product. They are higher efficiency, higher energy density, and they last longer than most other battery types. So lots of advantages there. They do have higher upfront costs. Some chemistries can be more volatile and are a little more hazardous. They are currently challenging to recycle, although that should get easier as time moves on. And they have specific installation requirements. Read your free manual and make sure that you know how those systems need to be installed. Thank you for joining me for this lesson, and have a great day.